Hello everyone, this is Chandra from the Department of Information Science and Engineering in 7th semester from the College of Sri Venkateswara College of Engineering in Bengaluru. So today we are discussing the subject called as in cryptography with the topic called as RSA algorithm. So no more late, let's go to the topic. So the RSA algorithm is widely used the public key cryptographic system to secure the data transmission. It involves generating the public and the private key pairs and use the mathematical properties for the large prime numbers. Here the steps involves the RSA algorithm key generation. Where in this key generation, the step 1 choose the two distinct prime number p and q. These should be kept separately. Where in this p and q are the two prime numbers, let us assume p and q are the two prime numbers which we kept separately as a secret. So in the step 2, calculate the n equals to p into q. N is used the modulus for the both public and the private key, where n means the modulus of the both public and the private key. We are multiplying the two separated prime keys, that is p and q. Where in step 3, calculate the pi of n is equals to p minus 1 into q minus 1, where the pi is Euler's Toit function which gives the count of positive integers lesser than n, and that is co-prime to n. While the step 4, choose an integer e such that 1 is lesser than or equals to e and the e is lesser than or equals to pi of n, and the e is a co-prime number to pi of n. E will be the public exponent. Where the fifth step, in the fourth step we found that e. So in the third step we found the pi of n. In the fifth step, calculate the private key d using the modulus multiplicative inverse of e, modulus of pi of n. In other words, the find d such as d into e equals to 1, the modulus of pi of n. D will be the private exponent. Where in the second step, encryption. To send the message m, there is two steps. Step one is convert the m into the numerical value, and they typically use the padding scheme. Where to convert the m into the numerical value, we're gonna use the padding scheme. In the step 2, compute the cheaper text C using the public key, where the C is equals to ME, which means the mod of n. Where we're gonna use the third step called as decryption, where in this two steps will be there. Step 1, receive the cheaper text C, and the step 2 is compute the original message M using the private key M equals to CD mod of n. So the fourth step is message transmission. Send the cheaper text C to recipient. Here the simplification, for example, let us choose the P equals to 11 and the equals to 3Q equals to 3. So the first step is calculating the n equals to p into q into 11 into 3 into that is equals to 33 we will get. So calculate the pi of n is equals to p minus 1. The formula is pi of n equals to p minus 1 into q minus 1, that is equals to 10 into 2, that is equals to we're gonna get the output as 20. Choose the e equals to 3 which is co-prime to pi of n. Calculate d such as that d into e equals to 1 mod of pi of n. In case d equals to 7, because 7 into 3 equals to 1. Mod of 20, 7 into 3 is equals to 1. So mod of 20. So suppose the message to be encrypted is mod equals to 5. The encryption C is equals to 53 of mod of 33 is equals to 125 mod of 33, which is equals to 26. The decryption is mx equal to 267 mod of 33 is equals to, we'll get the output as 5. So when come to the point of advantages of RSA algorithm, the security, the RSA is considered as security due to the difficulty of the factoring the large prime numbers, which forms the basis of its security. The security relies on the challenges of the factoring and the product with the two large prime, making the challenging the actors to determine the private key from the public key. Versatility. It's versatile and the widely used for the secure data transmission, including the encryption of the message, the digital signature, and the secure communication over the internet. Asymmetric encryption. It employs the asymmetric encryption, meaning different keys for the encryption and the decryption, whereas public and the private keys, and providing the secure way of data exchange over the unsecured challenges. Authenticated and the digital signature. RSA enables the creation of the digital signature, allows the authentication of the sender and the verification of the integrated of the messages. When come to the point of disadvantages of RSA algorithm, the first disadvantage is key size, and the second one is processing overhead. The third one is vulnerability to attacks. The fourth one is key management, and the fifth one is potential quantum computing threat. So, the key size is the computing the power increasing the requirement key size for the RSA to remain the secure also increases. The larger key size can be slowed down encryption and the decryption process, impacting performance and processing overhead. RSA involves a complex mathematical operation, especially with a large key size, which can computationally intensive and may requires more resources. The vulnerability to attacks is RSA can be vulnerable to certain attacks if it not implemented properly, such as site challenges attack, chosen cheaper text attack, and also attacks on the improperly generated keys. So, in the fourth point, key management, securely management and the distributing keys, and especially the private key is curable, and if the private key is composed, it can be composable as a communication encryption with the corresponding public key. The potential quantum computing the threat is the development of a quantum. The potential threat to RSA as in quantum computers and could be theoretically solve of the function problem efficiently and the potentially compromising the security RSA based on the encryption.